Okay, class, we are going to graph logarithmic functions now. Okay, so for the functions, we do have the base function, and we are going to have the shifts that go around the base functions. So for the logarithmic model, we are going to graph with horizontal shifts h and k, and we're going to do log with very bases a, and specifically the natural log, which remember is just log base e is the natural log. Okay, so our base function is the log base a without the shifts. It's going to have a horizontal shift h units and a vertical shift k units. Reflection across the x-axis if the function is less than 0. So if there's a negative out front, it's going to be a reflection across the x-axis. And recall that logarithms and exponentials are inverse functions, so they are just reflections of each other across the y equals x line. So if this is the axis and I draw in the y equals x line, the exponential function looked like this, and its inverse, the logarithm, is going to be a reflection, so it is going to look like this. So that is the reflection. So the exponential function had a horizontal asymptote. The logarithmic function is going to have a vertical asymptote. And the key points are also reflections of each other, because when you find it inverse, you swap the x's and the y's, or you reflect it across the axis. So the key points are also swapped. So the domain for this is also a swap of the domain of the domain range for the exponentials. So for the exponentials, the domain was all real numbers, so that becomes the range of a logarithm. And for our graph, for a logarithm here, you do see it going up and down everywhere. But the domain, it starts at 0, because that's where the asymptote is, and is positive. So the domain is 0 to infinity of a logarithm function. And you recall for exponentials, that was the range of the exponential function. And lastly, we do have the vertical asymptote, which is the equation x equals 0, because the vertical line going through x equals 0, which was a reflection from the exponential, where it was y equals 0. So let's go ahead and graph some functions. Okay, so I have the key points up here. We are going to graph the base functions y equals log base 5 of x, and when we graph it, we're going to do the base function, and then we are going to reflect, and then we are going to shift. So we're going to do it in this order: base, reflect, and then shift. The key points are 1 over a, so my a is 5, so it's 1/5 comma minus 1, 1 comma 0, and then a comma 1, which is 5 comma 1. So those are the key points we're going to plot for our base function. So we have 1/5 comma minus 1, 1 comma 0, and 5 comma 1. Okay, so this is going to be what the graph looks like of the base function, and it will have a vertical asymptote. Okay, so then we're going to go ahead and do our shifts and our stretches and reflections that we have. So the shifts is going to go left 1 and up 2. So left 1, up 2, and I'm going to draw my final answer in red. So we are going to go left 1, up 2, including our asymptote. So I'm going to start with my asymptote, going left 1 and up 2, should sit left 1. And my key points, this was at 1/5, and I'm going to go left 1, so it's at minus 4/5 now, up 2. This point, left 1, up 2, left 1, up 2. So this is my new function, which I'm going to draw in with a smooth curve with it approaching the asymptote. It only has one asymptote. It doesn't level off. Okay, So you should have it approaching your asymptote, not steering away from it. And I am going to put in my key values on the axes. I'm going to change my color. So this value was at -4/5. That value was 2, 3, 4, 5, 1. And that value was 1/5, -1. Don't have room to write 1/5 in, so I just labeled the point, and my asymptote was at -1, so I'm going to label that value as well. So your key dots should have the x and the y coordinate marked. So the domain, our red function has switched, it has shifted left, and we can see it going from -1 to infinity. It does not include -1 because there is an asymptote there, so it is a round bracket. The range is the y values, and it is all real numbers from -infinity to infinity. The vertical asymptote goes to the x-axis at -1, and the interval for increasing, well, it's increasing from -1 to infinity. It's always increasing, and it starts at the asymptote, and it increases always. Okay, so that is the first example. The next example has a reflection. So I'm going to go ahead and graph my base function first. Do my base function in red. My base function is y equals log base 2 of x. So the key points, with my a value being 2, it's 1/2, -1, 1, 0, and then a, 1, so 2, 1. So I have 1/2, -1, 1, 0, 2, 1. I have my vertical asymptote on the y-axis, and I connect the dots with a smooth curve. And I'm going to put my values in, 1/2, 1, 2, 1, -1. Okay, so then after we graph our base functions, we can go ahead and talk about our shifts and our reflections. So a negative out front tells us you make your y's negative, so we're going to reflect it across the x-axis, and then we have a shift right 3 and down 1. So I'm going to, remember, we're going to graph the base function and then do our reflections and then do our shifts. So we're always going to do it in this order. So we have our base function. So now we're going to reflect it across the x-axis. So the point down here gets reflected up, on the x-axis stays, and then that stays. When you reflect the asymptote, it stays. So this would be y equals negative log base 2 of x. I'm going to change my color and indicate that now I'm going to do it with the shifts in blue. So now I'm going to go right 3 and down 1. So I'm going to take my asymptote and go right 3. When I go down 1, it didn't do anything. Okay, so now I have my new asymptote. I'm going to take my point, which was at 1/2, 1, go right 1, 2, 3, and down 1. And I'm going to take my next point, go right 1, 2, 3, down 1. And I am going to draw in my smooth curve now. And I'm going to label my points, 3.5, 4, and 5 were the x coordinates of my key points. Okay, so now I'm going to find the domain. So my blue, which is my final, starts at 3 and goes to infinity. So it goes from 3 to infinity. The range is all real numbers. You see it going up and down forever. The asymptote is this blue line here going through the x-axis at 3, and intervals for decreasing. So from left to right, it decreases, and it starts decreasing at 3 all the way to infinity. It's the interval for decreasing. And notice that 3, 3, 3, it all has to do with the asymptote. Okay, let's go ahead and move on to the next problem where we have a fractional base. So our base function has no shift, so I'm going to graph y equals log base 1/3 of x. So I have a fractional base. It's the same idea. 1/1/3 is 3, 1, 0, and 1/3, 1. Okay, so we're just going to see what happens when we have a fractional base. So we're going to graph our base function. So I have my vertical asymptote at y equals 0 as initially, and at 1, 2, 3, comma minus 1, 1, comma 0, and 1/3, comma 1. Notice that this fractional exponent gave my graph kind of a reflection of sorts, and it's just a reflection of the graph log base 3. It's very similar to that. Okay, so we went ahead and graphed it, and we connected it with a smooth curve, and then we need to go ahead and do the shifts and the reflections. So we don't have any reflections, we are just going to have a shift. So we are going to change the color, and we have a shift down 1. So I'm going to take my point and go down 1. Take my points, go down 1. Take my points, go down 1. Your asymptote goes down 1, and you connect your curve. Smooth. Label your key points. Okay, so we connected the dots with a smooth curve, we show our asymptote, and we labeled all of our key points. The range and the domain is what we need to find next. The domain, it starts at 0 and goes out to infinity. The range is everywhere, is all real numbers. The asymptote stayed at x equals 0, and then increasing and decreasing. So the intervals for increasing and decreasing, well, it looks like it's decreasing always, and it starts at 0. And so the interval where it's decreasing is from 0 out to infinity. Okay, so graphing with a fractional exponent works exactly the same. You just use the same key points. Okay, so now we're going to do a natural log problem. So for the natural log problem, remember that this is just y equals log base e of x plus 1 plus 2. So our base function, which we're going to graph first, is y equals the natural log of x, which is log base e. So our key points are 1 over e, and figure out what that is approximately equal to, minus 1, 1, comma 0, and then e, so my base e, which is about 2.7, comma 1. And when you take your calculator and do 1 divided by e, or 1 divided by 2.7, that's about equal to 0.37. So we can go ahead and plot these points. So 0.37 minus 1, 1, comma 0, and 2.7, comma 1 would be my base function. And my base function has the asymptote at x equals 0. So I'm going to connect the dots with a smooth curve. Okay, so I did it dotted just because I know I'm going to have to do the shift next. So that is my base function with the value e, 2.71, and that value was 0.37, or 1 over e. So now I'm ready to go back to my red, where we can do the final answer, where it has a shift left 1 and down 2. So I'm going to take my asymptote, go left 1, down 2 did nothing, and then I have 0.37 minus 1, so my dot here, I'm going to go left 1, down 2, left 1, down 2, left 1, down 2. Okay, so I'm going to connect the dots with a smooth curve, and then I'm going to have to label my values on the axes. So this value is at minus 3, minus 2, and that was e minus 1, so 2.7, you subtract a 1, that was at 1.7, and that is 1 over e minus 1. Okay, so we need to find the domain. So the domain started at the asymptote, which is minus 1, and goes out to infinity, again with the rounded bracket. The range, it's always all real numbers. The asymptote was the vertical line, x equals minus 1, and this from left to right is increasing, and it's increasing on the interval from minus 1 to infinity. Okay, so graphing with the natural log, it's the same as graphing with the regular log. It's just base e, so you have to use decimals.